In order to solve logical equivalence, we were using truth table. So now we are going to solve this logical equivalence without truth table by already existing laws. Okay, so the first law which we are going to learn is the idempotent law. So what does idempotent law tell you is P or P is logically equivalent to P. The second one, P and P is also logically equivalent to P. The second one is double negation law. Okay, so what does double negation law tell you is the double negation of P would be equivalent to P. Next one is your associative law. So associative law, the same thing, P or Q or R, this will be equivalent to P or Q or R. And the second one, P and Q and R, this will be equal to P and Q and R. Okay, so next one is your distributive law. So according to the distributive law, you have P or Q and R. So this will be logically equivalent to P or Q and P or R. And P and Q or R, this will be equivalent to P and Q or P and R. Okay, next one, the important one is your De Morgan's law. Okay, that is not of P and Q. So when not is taken inside, it will be not P or not Q. Next one, not P and Q. So this would be not P and not Q. Okay, next one is your absorption law. So what does absorption law tell you is P or P and Q. So this will be equal to, so P and Q, whether it is P or Q, when you take with P, it will be logically equivalent to P. Likewise, P and P or Q. So again, when you take and with P, it will be equal to P. This is what your absorption law tell you. Next one is your negation law. So negation law, you write it as P or not P. Okay, so this will be equivalent to true. Next one, P and not P. So P and not P will be true. This will be false. Okay, this is your negation law. Likewise, another two more, the identity law. Identity law. So identity law tells you that P and true, this will be equivalent to P. Also P or false, this will be equivalent to P. And the last one, domination law. So what is domination law is P or true, this will be equivalent to true. P and false, this will be equivalent to false. Okay, so once we are thorough with these laws, then without using the truth table, we can solve the logical equivalence. Okay, now we are going to show that P or Q and not P and Q is logically equivalent to P. And this we are going to show without using the truth table. Okay, so the first step, you're having not and not here. Okay, so this not should be taken inside. For that, the law which we use is the De Morgan's law. Okay, so what does De Morgan's law tell is not of P and Q. If I have something like this, not would be taken inside, so it will be not P or not Q. Okay, that is what we are going to use here. P or Q and not is taken outside, so it will be not P and will become or not Q. Okay, so this is logically equivalent to this part. Next one, we are going to use the double negation. Okay, so what does double negation tell you is when you have double negation of that term, the double negation will get cancelled and you will have only the P term. So it will be logically equivalent to P or Q and not P would become P or not Q. Okay, next one, you have P or Q and P or not Q. Okay, so now you can see that you have like this is something connected with your distributive law. You have your or and. Okay, so you're going to use your distributive law. So according to your distributive law, how do you write this is P or Q. Okay, so what does distributive law tell us is if you're having P or Q and R, you can write it as P or Q and P or R. This is how you can write. So now you have this part, you're going for the reverse part. Okay, according to the distributive law, you can write it as P or Q and not Q. Okay, so now we use the inverse law. So this inverse law is nothing but you have Q and not Q. So Q and not Q, obviously it is false. Okay, so P or false. So now we are going to use the identity law. So according to the identity law, what we have is P or false. This is equivalent to P. So this is your identity law. So P or false will be equivalent to P. Okay, so we have proved that we have started with P or Q and not P and Q, and we have shown that it is equivalent to P. Okay, so this is one question. Okay, next we are going to show that not P or Q and R or not Q is logically equivalent to Q and R. Okay, so here since we have negation, first we'll go bring negation inside by using the De Morgan's law. So what you'll have is not of not P or Q is logically equivalent to not P or Q and R. So you have just brought this not inside the bracket. Okay, so now the whole thing will be inside the bracket, and then this not is applied to this or, so this will become and, then you'll have not Q. So this step is by using the De Morgan's law. Okay, next step by using double negation. So you have not, so you go for double negation. So not will become, not and not will go out. There will be P or Q and R. Again it is and Q. Okay, so you have P or Q and R and Q. So now we are going to use the associative property. So associative property. So what is associative property? You have P or Q or R means you can change the bracket and write it as P or Q or R. Okay, so here again it is and we are just going to change the bracket and write. So it will be P or Q and R and Q. Okay, now we are going to use commutative law. So what does commutative law tell? So like in the normal set theory, it is AB is equal to BA. So here P or Q will come as it is. The second part, instead of R and Q, you will write it as Q and R. Okay, so this is logically equivalent to. So now again what we are going to do is we are going to use the associative property. So according to the associative property, whatever we did here, the same thing you brought inside the bracket, now taking outside the bracket, so it will be P or Q and Q. So this will be in one bracket and R. Okay. Now we are going to use absorption law. So what does absorption law tell us? P or P and Q will be equivalent to P. So here P or Q. So P or Q and Q will be obviously equivalent to Q and R. Okay, so this is what we had to prove, and we had proved the second part of the question. Okay, next one we are going to show that not of P or not P and Q and not P and not Q are logically equivalent. So the left hand side would be not P or not P and Q. Okay, so first step we will bring the not inside by using De Morgan's law. So according to De Morgan's law, we'll just bring not inside, so it will be not P or will become and. So this will be not of not P and Q. Okay, so now again you are going to bring this not inside. This is to be brought inside. Again you using De Morgan's law. Okay, so it will be not P and not P or not Q. So now you have double negation. So you have to remove that by using double negation law. Okay, so not P and not P will become P or not Q. Okay, so this will be equivalent to. So here you have and or. So you go for the distributive law. So according to the distributive law, it will be not P and P, or not P and not Q. Okay, so now we are going to make use of the negation law. So according to the negation law, what does negation law tell you is P and not P will be equivalent to false. Okay, so here we have P, not P and P, so this will be false or not P and not Q. Okay, so now next one we are going to use the commutative law. So commutative law will have A, that is A into B, you'll write it as B into A. So here we are just going to write it as not P and not Q or F. Okay, so now finally we need our answer, we need it as not P and not Q. For that we use the identity law. So according to the identity law, P and true would be P and P or false would be P. So here we have, it is like P or false. So P or false would be equal to P. So here P is not P and not Q. Okay, so this is what we had to prove.